Here's the number one thing you should not do when you suspect that you have a bad motor or a bad ESC. Here I've got my quadcopter plugged in on the bench, and I'm just going to hold it down with my hand. Let's just make sure all my fingers and toes and all my other appendages are out of the way, and oh yeah, no, that motor's not spinning all right. So what now? I'm Joshua Bardwell, and you're going to learn something today. Well, the very first thing we're going to do when we've got a bad motor or ESC, or anytime we're troubleshooting on the bench, is we're going to take off our props. Never have your battery plugged in and your props on the bench at the same time. Well, if you're using a smoke stopper, maybe you could get away with it. But we're going to need to spin these motors to test them, and a smoke stopper wouldn't let us do that. So props off for safety. Now that the props are off, how do we know that the motor or ESC is broken? And the number one symptom that you're going to see is that when you arm the quad and try to spin the motor, it twitches instead of spinning. Now you can't see this, but I can also feel that when I spin the motor, there's a lot of resistance there. Let me see if I can demonstrate that for you. Here is a good motor, and you can see the bearing doesn't sound real great, but the motor spins pretty normally. But this motor, which we suspect to be bad, if I try to spin it, you can see it just will not spin. It's really bound up. When we have a situation like this where a motor twitches but does not spin, it almost always points towards the ESC, the motor, or the wiring in between them, but not the flight controller. Why not the flight controller? Because a flight controller, all it does is it tells the ESC how fast the motor should be spinning. And then it's up to the ESC to actually make the motor spin that fast. So you could imagine a situation where your idle percent in beta flight was too low, especially if you had a really big heavy motor that needed a higher idle speed to get it going. And when the flight controller said to the ESC, let's get the motor going, that value, that throttle value that the flight controller was sending was too low and the motor didn't start spinning. But what you would see there was kind of a boosh, 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 like when you raise the throttle slider in the Betaflight Motors tab. And you wouldn't see that kind of tick, 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 like we're seeing here. So the twitching motor that we're having is either related to the motor, the wiring to the ESC, or the ESC itself. And you might think that the fact that the motor is physically bound up, it's dragging, would immediately point to the motor itself as the problem. And you're right, but not 100% of the time. Yes, a mechanical problem with the motor, like a damaged bearing or a bent shaft that's allowing the motor bell to rub on the magnets, could cause the motor to drag. But I'm going to bring in this perfectly good RC power motor to demonstrate that there are also electrical things that can cause the motor to drag. And so if I just take the motor and spin it, it just spins normally. But if I take two of the motor wires and touch them together and short circuit them to each other, well, you'll have to take my word for it. You can do this test yourself. There is more drag on the motor, and the motor will slow down faster. And the reasons for that are outside the scope of this video, but suffice it to say that if you have an ESC that has a shorted out FET, it can cause those motor wires to be shorted together inside the ESC, and that can also cause motor drag. And there's a difference in feel between mechanical drag and electrical drag. So we're going to start our troubleshoot with a physical inspection of this motor, and we're just going to look and see if we can find any defects. And the first thing I'm going to do is I'm going to look at the motor edge on, and I'm going to rotate the motor bell, and I'm going to look at this gap right here between the motor bell, the bottom of the bell, and the arm, or maybe the gap between the base and the bell. But I'm going to eyeball a gap like that, and I'm going to just rotate it, and I'm going to see if that gap changes size. You could even use a caliper or a feeler of some kind to measure it. But what I'm looking for here is whether the shaft is bent and the bell is off center. And I don't see it. It looks pretty freaking square. It looks pretty dead on. I don't see any wobble there. So I don't think we have a bent motor shaft. We're going to go back to this RC and power motor for this next point because we need to look up inside the motor, and it's not easy to see that when it's actually mounted on the quad. What I want you to see is that the motor is constructed of a steel ring which has magnets glued to it. These are the individual magnets. And then from there are stator poles, the poles of the stator here. And if the shaft is bent or if the bell is out of round, if it's an oval instead of a circle, what we'll see is, and we'll feel, is that as we rotate the bell, there will be a rubbing at certain points. It's usually not all the way around. It's usually like right here you'll feel a rub and then it'll release. And that's another thing we're going to check for when we're doing our physical inspection of the motor. But with this motor, I don't feel any rubbing at all. It is perfectly smooth all the way around. It's just that there is a sort of a constant drag. And here's the other interesting thing. The faster I spin the motor, the more there is drag. It's almost like pulling an oar through the water. If you go slowly, there's very little drag. If you go quickly, it pushes back harder. And that to me is telling me potentially that we have an electrical problem in the ESC. That is characteristic of that type of electronic drag as opposed to a mechanical problem with the motor. But let's proceed with the troubleshoot and see where it goes. Another check is to look at the windings here from the top and see if there's any sign of damage, specifically looking for discoloration or burned spots. Sometimes you can also smell it. If you literally put your nose up to the winding, you can smell the burned enamel. I have had cases where I slightly smoked a motor, but then the motor continued to work fine. I didn't burn all the way through the enamel and the motor was still functional. In general, though, if you've got a case where a motor doesn't spin and there is any sign of damage to the windings, discoloration, or black scorched spots, that's a sure sign that the motor is just cooked and you just need to replace it. The other mechanical check that I like to do on a motor is to check for vertical play. And what I'm going to do is I'm just going to push or pull up and down on the motor and feel how much vertical play there is in the shaft. And this motor has like literally none. You can't see and I can't feel any movement. There could be as much as maybe 0.5 millimeter of vertical play. And so, like some motors, like the iFlight motors, have a little bushing inside the motor as a shock absorbing. So you may get a small amount of vertical play depending on the motor's construction and how tight the motor screw is on the bottom. But if you got a motor with more than about maybe 0.5 millimeter of vertical play, that may not cause the motor to refuse to spin, but it certainly isn't helping your gyro, and it could indicate that the motor has been subject to enough damage that it needs replacing. Anytime you're dealing with a bad motor or bad ESC, you're always going to want to have one of these. And this is a ViFly Short-Saver, and it's like an electronic circuit breaker. When there's overcurrent, it will trip and cut off the circuit and prevent damage. Except a circuit breaker it trips way faster than a circuit breaker, like in sub-millisecond time, hopefully before any damage can be done. The ViFly Short-Saver is the one that I think is the best. I'll put a link in the video description if you want to pick it up. There are other ones out there, smoke stoppers and so forth. They all are fine, but this is the one that I like to use. So we're going to plug a battery into the smoke stopper or Short-Saver. And then this option here, the blue light means we're on a 2 amp setting. The no blue light means we're on a 1 amp setting. I always like to start on 1 amp because you want the lowest trip point as possible. It will minimize the odds of damage. We're going to plug in here, and then we're going to power up the quad. Now, the ViFly Short-Saver has an on-off switch, which I'm going to use to power the quad up and down. If you don't have that, then you can just plug in and do what I'm about to show you. And what I'm going to do is pinch the suspect motor in my fingers, and I'm going to power up the quad. And you know how when a quad first powers up, it goes doo-doo-doo, doo-doo. Well, it turns out that's the ESC making those beeps. And the actual speaker that's making the sounds, where is it? Where's the speaker that's actually making those beeps? It's actually the motors. The ESC can vibrate the motor coils in such a way that it actually makes sound. In fact, there's actually custom ESC firmwares out there that like literally make your ESCs talk or can play, I don't know, a sound file. But BLHeli doesn't do that. It just goes doot-a-doot, doot-doot. And you want to understand what those beeps mean. The doot-a-doot means that the ESC is powered on and talking to the motor. It makes the motor beep. And then the doot-doot means that the ESC has seen signal from the flight controller and is ready to spin the motor. But we can't just listen, because if we've got one good motor, we're going to hear those beeps from the good motor. We want to know what the bad motor is doing. And that's why we're going to pinch it in the finger and feel as well as hear the beeps. Here we go. Ready? Okay, 1 amp didn't cut it. Let's try 2 amps. No, it's tripping again. Well, that's a shame, but it's also a great demonstration. So the smoke stopper tripped on 1 amp and it tripped on 2 amps. At this point, what some people would do would go, frickin' smoke stopper, what's your problem? And they would plug in the battery and then something would smoke. What the smoke stopper is telling us is that we have a short circuit somewhere in this quad and it is protecting us from smoking whatever has the short circuit. So where do we go from here? Well, the good news is that this quad is the Rotor Riot solder-free build, which means it has MT30 connectors on the motors, and it is super easy to just unplug this motor, or if you didn't have that, you would desolder the motor and see if the short circuit condition goes away. Anytime you have a short circuit, you just start desoldering things and see where the short circuit is. By the fact that the short circuit goes away when you disconnect the thing that has it. So here we are again, we're on 1 amp and we've got the motor unplugged and we're going to try again. Okay, well that it started to go, but the 1 amp I think was not enough. So let's go to 2 amps. Okay, perfectly normal. So the smoke stopper tripped when we had the motor connected, but it didn't trip when we disconnected the motor. And that's certainly starting to look like we have a bad motor. Let's talk about motors and how they go bad. Because we've identified that we don't have any obvious mechanical defect in the motor. We checked the motor to see if the shaft was bent or the bell was rubbing. The bearing felt okay. Everything seemed basically okay in that motor. But the electrical problems are much harder to figure out. So I'm going to put my multimeter into continuity check mode, and that's the mode where when there's electrical continuity between the probes, you get a beep. And normally that's how you chase down a short circuit. You test for continuity, and if there is continuity, then you have a short circuit, and that tells you where the short circuit is. But that doesn't work with brushless motors. Watch, this is a perfectly good brushless motor, and I'm going to check for continuity between the motor pins, and sure enough, continuity is there. And the reason for that is that brushless motors always have electrical continuity between the motor wires. So why don't they just short circuit and fry the minute you apply voltage to them? And the answer is that the ESC has the ability to control the amount of current going through the motor. And when it drives the motor, it just doesn't let a short circuit happen. Why is it bad? Why is this motor bad because it has a short circuit, and this motor isn't bad when it also has a short circuit? But it turns out that if there is a connection between the motor wires anywhere other than the very end of the wires, so the wires go into the windings, they wrap around the windings in a certain pattern, and then in the very center, the wires come together. And if the motor has been damaged, for example, it's been overheated and the enamel coating of the wire burns off, you'll get a short circuit between the two wires, between the two phases, where it's not supposed to be. And then you end up in a situation like we just saw here, where you have a bad motor that causes the smoke stopper to trip. But the takeaway of this situation is that you cannot use a multimeter to test for short circuits in a DC brushless motor, at least not the kind of multimeter that most of us have. You need a very, very sensitive multimeter that can measure down in the milliohms, or you need something called an inductance or Henry meter, which can measure the inductance of the motor coils to tell you that it's bad. Now in this situation, we have pretty definitively identified that this is a bad motor, but I don't want to just discuss this exact situation. I want to give you tips for troubleshooting in general. What I might do next, if I wasn't sure, is I might disconnect the motor from the ESC and see if there still was that drag on the motor or if it now spins freely. The short circuit that is causing the drag on the motor could be in the motor or it could be in the ESC. If we disconnect the ESC and suddenly the motor spins freely, that points to the ESC as potentially having a blown FET. And there actually is some troubleshooting you can do with a multimeter if you have an ESC that you suspect has a blown FET. I'm not going to go into that in this video, but I'll put a link down in the video description to another video I made that goes into that in more detail. So next thing we're going to do is we're going to take this motor off, and we're going to swap it with a good motor, and we're going to see if that fixes the problem. Anytime you're taking motor screws off and you have an even partially stripped screw, throw it out and replace it. It's only going to get worse from there. You're going to end up with a motor you can't change because You're stuck in the field with a stripped motor screw. So here is the ESC wire where the bad motor was. We're going to take the good motor and we're going to plug it in there. I don't even need to mount it. We're going to take our battery, we're going to plug it in, and we're going to power up. Perfectly good. So at this point, for this specific troubleshoot, we have definitively identified that this motor is bad and basically need to discard it and replace it. But we're not going to stop there. Like I said, we're going to continue the troubleshoot so you could solve other problems. And what I said you should do is pinch the motor and feel how many beeps there are. Boop, boop, boop. Boom, boom. And I can feel all 5 of those beeps. So what does that tell us? When you feel the first 3 motor beeps, boop, 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 that pretty much tells you that the ESC is good. It's not 100%, but it pretty much tells you the ESC is working as it should. The ESC has power, and the ESC is able to drive the motor poles at least a little bit. If you didn't feel those beeps, or if those beeps were much weaker on one motor than on the others, then that could potentially tell you that there was a problem with the ESC or the motor. But if we feel those 3 beeps real strong, we can conclude that any problems that we're having are probably not related to the ESC or the motor. The last 2 beeps, boop, boop, that tells us that the ESC is seeing throttle signal from the flight controller. So if we felt the first 3 beeps, but not the last 2 beeps, that might be if you didn't select a motor protocol in Betaflight. Betaflight ships with, when you first flash it, the motor protocol is disabled and you need to set it to DShot 600, DShot 300 or whatever. If you've left it on disabled, you'll get boop, 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 but you won't get boop, boop. If you had some super old ESC that didn't support DShot, and you had your flight controller set to D-Shot, you could get boop, 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 but then not the last 2 because it just doesn't understand the input throttle signal that it's seeing. The other thing that could cause the missing last 2 beeps is if there is a problem with the wires connecting the ESC to the flight controller. Are you kidding me right now? Hey there, it's Joshua from the future. I know why Joshua's ESC is not making any sounds. Right now, he's terrified that it's a bad ESC, and he's literally had this ESC die on him in the middle of the video, but that's actually not what it is, and he's just about to show you how he figures that out and what it really is. But before we do that, if you're enjoying this video, if you're learning a lot, and if you think more people need to see it, would you mind going down and hitting the like button? It sure does help the analytics. It really means a lot. Okay, let's go watch Joshua squirm. Well, what I wanted to happen was to power up the ESC with the ESC wire unplugged so the flight controller was not connected, and what I expected to hear was doot-doot-doot with no doot-doot. But instead, it brings us to the next thing that you could get, which is no beeps whatsoever. If you plug in the battery and you feel or hear no beeps whatsoever, that tells you that your ESC is not getting power or your ESC is dead. And in the case of a 4-in-1 ESC like we've got here, we get a little bit of additional troubleshooting information because we didn't hear any beeps at all, which means none of the 4, if you had a 4-in-1 ESC, you could have 1 bad ESC and 3 good ones, and you would still hear doot-doot-doot, doot-doot. You just would have to pinch the motor to feel that one of them wasn't beeping. But in this case, we have none at all, which is a beautiful opportunity to continue troubleshooting. And the first thing I'm going to do is just get my battery checker and see if I've killed this battery by accident. No, it's at 4 volts. Well, in theory, if the battery was dead, then we could get no beeps. Although usually you would kind of hear boop, 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 you wouldn't get no beeps at all. Well, here's the next check that I would do. I would plug the battery in. I would power up. I'm going to have my smoke stopper turned on for safety. I'm going to get my multimeter out, and I'm going to check at the ESC power pads that the ESC is getting voltage. And I don't see how it could not be, but you never know. I'm going to be real careful not to short circuit anything here, although I do have my smoke stopper as a safety check. How many volts have I got? Oh, I'll use the legs of the capacitor. That's an easy way to do this. Oh, no voltage. There's something wrong with my smoke stopper? Is my smoke stopper not outputting voltage? It's not. Has my smoke stopper died? How? Let's that's not my ESC. ViFly, I vouched for you. What are you doing? I got another one. I got another ViFly. Let's check it. Okay. Voltage, ladies and gentlemen, 15 volt. That's what we should see. That's what I expected to happen. I don't know why, but my smoke stopper seems to have suddenly died on me at the best possible time to demonstrate more troubleshooting opportunities. So that was an example of three beeps, doot-doot-doot, and an example of no beeps and how to troubleshoot that. In the case where you get no beeps at all, the first thing I want to do is verify that the ESC is getting power at all. And I do that with a multimeter. I test with a multimeter to see whether there is voltage on the power pads. And in this case, we saw 0 volts, which told us the ESC was not powering up. And then I sort of chased that problem upwards from the ESC to the battery. Right? Do I have voltage coming out of the battery? Yes. Do I have voltage coming out of the smoke stopper? No. Huh. Well, there's your problem. If you have voltage getting to the ESC and there is no beeps at all, the ESC is dead. It's just dead. Sucks. But that's the conclusion. So we've discussed a damaged motor and a damaged ESC. What about the situation where you have a damaged flight controller? And this one is frankly more rare of the two. When flight controllers die, they tend to die by like the 5-volt regulator dies and the whole flight controller shuts down or the gyro goes bad. But the individual motor outputs on a flight controller are not usually the first thing to go. But let's discuss that situation anyway. What you're going to see when you have a bad motor output on a flight controller is, number one, the motor won't spin at all most of the time. You'll get doot-doot-doot, but not doot-doot, and that again tells you that the ESC is working fine probably, but the flight controller is not talking to the ESC. At that point, you have to decide if there is an issue with the flight controller configuration or if there's an issue with the wiring. Now, when I say issue with the wiring, what I mean is you have to literally inspect the wires. Do you just literally have a broken wire? Give a tug on the motor wires. Did you build this plug yourself and you didn't insert one of the plugs all the way and it's not making contact? Unplug the wire and look in there at those pins. You can barely see them, and see if one of those pins is bent over and not actually making contact. Look on the ESC and the flight controller and just inspect the wire. Is it pinched in a standoff and getting cut? But literally just inspect the physical connection between the ESC and the flight controller. If that's not the issue, then we can think about the flight controller configuration. And the first thing I'm going to do is I am going to look in the motors tab. And if I have a quadcopter, I want to see 1, 2, 3, 4 motor sliders there. You can get in a situation where if you have messed up the resource assignments, if you've been trying to remap motors, or if you've been playing with the mixers, like you're trying to build a hexacopter or an octocopter, but you've accidentally set the flight controller to be a quadcopter, then you will see that there's missing motors there in the motors tab. At that point, you got to fix the configuration, set the mixer correctly, or if you've been playing with motor remapping and you've screwed it up, you may need to just reset the configuration of the quad entirely, put it back to defaults and start from scratch, and that'll at least get them working again. Now, if you do discover that your flight controller has a bad motor output, there are ways you can fix it. You can reassign that motor output to a different pin or pad on the flight controller. It does mean that you won't have all your motor wires in one little neat plug. You're going to need to take it out of the plug and solder it somewhere else on the flight controller, but at least you can keep the flight controller alive. I've got a video about how to do that. I'll put it down in the video description if you want to see that tutorial on motor remapping. Unfortunately, sometimes it is actually the ESC that is the thing that is dead. Not the ESC motor drivers, but the actual motor input signal on the ESC. That's the problem. How do you tell which is which? So you've got a case where the ESC is not seeing motor signal from the flight controller, and you're not sure whether the flight controller's output or the ESC's input is the problem. What I'm about to show you is a giant pain in the butt, but it is a way to answer that question. And if it saves you a $60 or $70 or $80 ESC, it'll be worth your time. The first thing you're going to do is you're going to identify, based on the pinout diagram of your ESC, which of these motor wires is the suspiciously bad one. If it's motor number 1, 2, 3, or 4, you're going to look at that pinout and you're going to identify this is motor number 4. And then what you're going to do is you're going to remove that wire from the plug, and you're going to pick any other motor and you're going to remove it from the plug, and you're going to swap them and put them back in the plug. And at that point, you've swapped the motor outputs at the ESC. And at that point, if the bad motor, if the motor that's not getting those last 2 beeps moves, that tells you that it's the flight controller that has the problem. And if it doesn't move, that tells you that it's the ESC that's having the problem. Think that through if you need to. That's how you figure that out. By the way, if you've never done this before, the way to remove these is you get like a little thin knife, like a razor knife or a utility knife, and you lift this little tab right here, come in from the side and lift this little tab, and then just pull outwards. And then what I like to do is just push down on the tab gently, and then reinsert the wire. And then that's how you switch them. Make sure you put those wires back in right side up. They can go in upside down. Look carefully at the wire when it comes out, at which direction it's facing, and make sure you put it back in facing the same direction, or it won't work right. Now, this whole time we've been talking about troubleshooting this quad, and I've been kind of waving it in front of you. A solder-free build. That's true. You can put this whole quad together without ever picking up a soldering iron. Not the flight controller, not the ESC, not the air unit, nothing. And on top of that, you don't have to connect it to Betaflight or BL Heli to get it going. And to put this idea to the test, I brought my friend Ken Herron out. Ken has a channel about DJI drones, but he flies FPV drones, but he doesn't know a ton about building them. And I invited him to come build this drone. In fact, this is the very drone that he built. If you want to see that, I'll put a card on screen. It's pretty hilarious. He's a ridiculously funny guy, and I think it's well worth a watch. That's gonna do it for this video, though. I'll see you over there. Happy flying.